Hi everyone, thanks for attending the remote presentation. I'm Peng, working in the personalization infrastructure team at Netflix. Today, I'm going to present a joint work with my colleague Eugen on the model lifecycle management system at Netflix, which we name as Runway. There are thousands of active machine learning models that drive Netflix personalization, and Runway is responsible for managing all those models. In this talk, we're going to cover four main topics. What has motivated us to build Runway? What features are available now? How did we make some design decisions along the way? And what more features or support do we plan to add to Runway? There were several pain points that we faced before we built Runway. Few of them are: as we hire more researchers, we see that there's a steep learning curve for new researchers to understand the setup of existing machine learning pipelines. Basically, there isn't much insight into the producer and consumers of a model. It is also not easy for new researchers to understand, for a specific model, what data is used, what features are generated, which data is used for which features, what transformations are applied, etc. Model releasing is fragmented in multiple places because of our polyglot workflow schedulers and multi-language support. Also, without a comprehensive model validation strategy, our researchers had published bad models that had brought down our inferencing systems. Our customer teams have different ways and use different tools to do monitoring and alerting. Also, our researchers sometimes forget to disable a machine learning pipeline that is no longer used in production, or if we decided to not roll an A/B test out. So some computing resources were wasted. These pain points had motivated us to build a model lifecycle management system. We name it Runway, not just because it's a system about models. Our hope is that models can take off smoothly and continuously with our system. Today, Runway is managing thousands of models for personalization at Netflix. Currently, Runway provides a store to keep track of models, its associated data and lineage, for example, producers and consumers. It allows researchers to search and visualize model structure and metadata through a UI. Runway validates and releases models in a standardized fashion, also can monitor and alert for model stillness. Runway has a multi-language SDK to allow easy interaction with Runway. Supporting all these features helped us drastically reduce the number of instances when we released bad models, and also at the same time increased our research productivity to better understand our model and to deploy our rollback models. In the next few slides, we're going to show you more detailed features provided by Runway. There will be some screenshots of our UI with some confidential information blurred. Runway makes it easy to discover models. On Runway's homepage, users can search models by anything that defines them. For example, model name, the owner of the model, input data, name of the transformations applied. One can also search by feature name, which will return all the models that use the feature. Here is a screenshot when I search for 21703, which is an A/B test number. Runway will suggest items based on the relevance, and once you hit enter, it will do a full text search and show all the results. Runway is able to track metadata and the configurations of model instances. A model can have multiple model instances. You can think of a model instance as a version of the model. For each model instance, Runway has links to the pipelines and the specific run to the jars and model files so that users can inspect the log of the training job or download model and jars if needed. Internally, we use a PubSub system to deploy an offline model to online. On the model instance page, you can also see the publication information and the environment, like which topics it published to. The alerting configuration. Different models have different thresholds. Here, the stillness threshold is 48 hours. And also the validation configuration and results. In this screenshot, the validation is about whether this model can be loaded onto an application cluster. If the validation fails, the error message will be displayed on this page. Runway makes it easy to understand a model instance through visualization. For each model instance on Runway UI, you can visualize model structure and understand the data lineage, like how the data was used, what transforms and feature encoders were applied. Our production models are usually very complex. So to illustrate this functionality, here is a screenshot of the visualization of a fake dummy model. Now it's clear to see the data lineage. To get more details about the transforms and features on Runway UI, there are detailed table views on different tabs. For example, here is a screenshot of the feature encoder tab. You'll see all the feature encoders used by this model instance. And if you expand a specific feature encoder, you can see the details like the inputs and the outputs. And also there's also a link to the source code of the feature encoder. Oftentimes, it's useful to have a monitoring timeline to get an overall understanding of when and how often a model is published, when the model was stale, and to spot potential problems, what is the corresponding alert, etc. Runway has a monitoring tab for each model where you can see a timeline of the model's publication history and alert history. You can zoom in and out by adjusting the time range. Each green dot represents the publication of a new model instance. Each red bar represents an alert, and the length of the bar shows how long it took to resolve the alert. On the same page, there are also some metrics and also the details of all the alerts. With Runway, it's also simple to understand which online application clusters consumed a model. On the App Consumers tab, you can see all the clusters that have loaded the model and which model instance was loaded. There are dashboards provided by our internal teams that show when the model was loaded and when loading failures happen, if there's any. Some models will use the score or prediction of another model as a value of its feature. In this case, we call them parent models and submodels, respectively. Runway surfaces all the parent models that use the current model as a submodel in a table. The information in the table is deeply linked to the corresponding Runway page so that you can navigate around. This is something we have been trying to do everywhere, so it's easy for people to navigate inside Runway and also to jump from Runway to other systems. It's handy for debugging and troubleshooting. Runway also provides global views of models, including unused models, stale models, and alerted models. On the unused models, you can see which models were trained in the last 7 days, but not used recently or never used. We can use this page to find which models do not need to be trained anymore to save some computing resources. You can see which models have open alerts on the alerted model page, and when were the alerts triggered and who was alerted. The stale model page shows something similar. On both pages, you can search the models and retire them in a batch fashion. Runway will also auto-retire open alerts if models are no longer active. So far, we have covered most features from a model-centric UI. These features are mostly used by researchers and engineers from offline teams who produce the models. Runway also has a cluster-centric UI, which allows our application team to interact with Runway. Due to the time limit, I'm going to skip the cluster-centric UI and briefly talk about a few other important features we have built. Before Runway, each of our customer teams had their own way to validate models and monitor model stillness. Now, they have migrated to use Runway as a paved path to do these things. More specifically, when a model goes live, you probably want to ensure that future publications of this model will not break the online apps. In the past, we have added new features offline and deployed the model only to realize that we didn't update our scoring system to include computing these new features online. Runway will ensure that the model can be loaded in the specified cluster before publishing. Sometimes some human mistakes can cause model overwrites. Runway will ensure a model is published by at most one active pipeline before publishing it to prevent unintentional model overwrites. Runway SDK allows users to easily configure stillness alerting, including the stillness threshold, whom to alert, and there are different alerting activation policies to choose from. For example, since Runway knows the consumers of a model, we designed a policy which only alerts if the model is actively consumed. So our users do not receive false alerts on models they do not care anymore. Next, let's move on to the architecture of Runway and some design decisions we have made along the way. Let's quickly review the flow of publishing and deploying machine learning models for personalization at Netflix. Most of our models are refreshed daily or hourly. We have offline pipelines which run in our orchestration system or notebooks that train models and write the model files to S3, and then publish a message with the model's location to a pub subsystem. Once the online application hears the new announcement, they will load the model and make inferences with the new version of the model. Now let's take a look at the architecture of Runway and see how it fits into the existing flow. Instead of saving and publishing models directly, the training pipelines and the notebooks now use Runway's SDK to talk to Runway's backend. Runway will parse the model and extract its associated data, save the information to a database, and then publish to the pub subsystem to notify the online apps. Runway's backend is coded in Scala. We use Akka HTTP to provide an HTTP API that gives a great deal of flexibility. The UI and our SDK are both built on top of this HTTP API. We chose to use AWS Aurora, which is a relational database, to save the model-related information for 3 reasons. First, there are mature toolings to do schema and data migration, and we used Flyway. And second, it offers query flexibility that enables us to answer sophisticated questions with good performance. And third, AWS Aurora takes away the maintenance burden as it's easy to snapshot, restore, scale up and down a database, add a replica, etc. We have a Java SDK and also provide thin Scala Python clients, both of which are built on top of the Java SDK. The Java SDK enabled an easy bridge for Python via Py4j. Our UI is built with React, which is component-based and declarative. It provides a good level of abstraction with shareable components and is relatively easy to debug and fast to iterate. In order to collect which online clusters consume or subscribe a model, there's got to be a way for online apps to talk to Runway. Our application clusters can have thousands of instances. If all instances talk to Runway when they load a model, usually around the same time, it's easy for Runway to become a bottleneck or a single point of failure. Since Runway is a key system in our machine learning workflow, we need to make it scalable and robust. To solve this issue, we log data, for example, what model version is consumed, what models does an app subscribe to. We log such data from the apps to Kafka, which writes to Hive, and we then process asynchronously in Spark as a periodic batch job, and eventually save the aggregated information to Runway database. Our stillness check is also a batch job that runs every 10 minutes. Finally, we offer an integration with our internal orchestration system. It made a smooth onboarding experience and gave us a hook to collect more data about pipelines producing the models without having the user manually supply everything. Also, most production models are orchestrated with these systems. Thus, it's very important to provide a nice integration. Throughout this project, we have been interacting with our customer teams closely, and we prioritize tasks based on their requests. There are some items undergoing and on our roadmap, and we'd like to share with you. We'd like to offer parameter tracking, which allows users to tag models with various sorts of parameters, including hyperparameters. Currently, online apps subscribe offline models by specifying the topic name through a pub/sub system. Ideally, Runway can abstract the topic name away and allow online apps to select models by parameters. We have seen production issues where bad models were trained and published due to different reasons, including low quality training data. We hope to provide model quality guard that validates input data before training and validates model metrics before publishing. It would be great to have model interpretability and debugging tools, either in a visualized way or can answer what-if questions when we need to debug a model if online metrics turn out to be a surprise. Currently, rollback a model through Runway is easy. Basically, you just need to announce a previous model instance, but it doesn't revert the codes. We hope to synchronize rollback of models and codes in an automated fashion. That's all for this talk. Thank you again for attending. And I'd like to thank my colleague Eugen and my manager Prasanna. If you have questions, please feel free to ask. Thank you.